Hi everyone, this is Mr. Ruhoy, and this is an Algebra 2 video for sketching polynomial functions. In this video, we're going to look at two things that are going to help us sketch these polynomials. The first being that we're going to look at end behavior, both the left and right hand end behavior. And then we're going to look at how to find the zeros. The way we find the zeros, solve for them, would be factoring, using factor by grouping. And then we would do a t-chart and solve for the roots, solve for the zeros. So let's get started with end behavior. So what we want to do is we want to look at our function. Right here, the first example we have is f of x equal to a cubic function. So this is a third degree function. The degree of this function is 3 because the highest exponent, the greatest exponent for this polynomial in each term is 3. Now that's important because when you look at what the degree is, you want to look at whether it's an odd or even number. In this case, 3 is an odd number. And what that tells us is that the left and right hand end behaviors will be different. On one side of the function, on one side it's going to be rising, it's going to be approaching infinity. And on the other side, it's going to be decreasing, it's going to be approaching negative infinity. We just need to figure out what's happening on which side. And the way we can figure that out would then to be looking at the leading coefficient. So both looking at the degree and the leading coefficient tells us that in this case, if I were to draw a quick sketch of it, it means that both left and right hand end behaviors are opposite. But because the leading coefficient is a positive number, in this case it's a positive 1, that means that it's going to be approaching infinity on the right side and approaching negative infinity on the left side. And this is the notation for that. If the leading coefficient were to be negative, then it would be switched. As x would approach infinity, it would be going down, and then as x approaches negative infinity, it would be going up. So whether the leading coefficient is positive or negative, that tells you which direction is going. So once we have our end behavior, then we want to start factoring. We're going to have to set our polynomial equal to 0. And what we want to do is we want to use factor by grouping. So if you group first two and the last two terms together, we can start by finding GCFs for them. So the GCF for the first two terms would be x squared, leaving us with an x plus 4. And the GCF for the last two terms would be a negative 1. And this is important because if you look at them, they both have both this first term and the second term, they both have an x plus 4. So that x plus 4 is GCF, and we can factor that out. So once you factor out the x plus 4, that leaves us with x squared minus 1. And hopefully you recognize that as a dots, a difference of two perfect squares. And that can also be factored. So finally, we end up with that. Once we're there, we can do a t-chart, where we set each of the factors equal to 0. So then we get x equal to negative 4, x equal to negative 1, and x equal to 1. And those are the zeros. Those are the x-intercepts. So once we have those x-intercepts, now we can come up with a sketch. So just approximating where this is, negative 1, 4, positive 1. So we have a 0 right here, here, and here, approximately. Now we know that the end behaviors tell us that as we approach positive infinity, our function, our y values are increasing. And as x approaches negative infinity, the function f of x is approaching negative infinity. It's falling. So that means that our sketch looks something like this. Something like that. Now to get a more detailed graph, we would have to find min and max points. But we know what the end behaviors are, we know what the zeros are. That's an approximate sketch of what this polynomial looks like. All right, so let's take a look at another example. So we have, in this case, we have g of x equal to x to the fourth. So this is a fourth degree polynomial. The largest exponent in this polynomial is 4, so that's the degree. And that's an even number. So when the degree is an even number, that means that both the left and right hand end behaviors are either both increasing or they're both decreasing. So they're doing the same thing. The end behaviors are the same. So to figure out whether they're both increasing or both decreasing, we need to look at the leading coefficient. And the leading coefficient is a positive 1. It's a positive number. So if it's a positive number, that means that on the right side and the left side, our function's increasing. If the leading coefficient was negative, that would mean that they would both be decreasing. But here's the notation for that. As x approaches infinity, as we approach the right side, f of x, our function, is rising. It's approaching infinity. And then as x approaches negative infinity, that means that our function f of x is also approaching infinity on the left side. So once we have our end behaviors, then we can start factoring. Now this one is going to require a little bit more factoring than the previous question, because this is now x to the fourth. But what we can do right away is we can factor out the GCF. The GCF would be x. And I decided to use brackets because there's going to be multiple sets of parentheses here. So I feel like the brackets can really help separate out the problem. So now what we need to do is we need to use factor by grouping. We can group these two terms and these two terms together. And the GCFs for each of those would be x squared. And the GCF for the second two terms would be a negative 1. And once you do that, you notice that we have an x minus 2 in both of these terms. Here we have an x minus 2, and here we have an x minus 2. So that means that we can factor out an x minus 2 right here, leaving us with x squared minus 1. Now x squared minus 1, that's a dots. That is the difference of two perfect squares. And we can factor this dots problem as x plus 1 and x minus 1. And I just want to point out that the x that we had right here, this x, it stays with us through each step. So finally, we want to do a t-chart. So we're going to set each of these factors equal to 0. And we can solve. So we have x equals 0, x equals 2, x equals negative 1, and x equals a positive 1. And those right there are our factors. And this guy out here. So finally, if we want to draw a sketch of this, we have 2. So we have 0, 2, negative 1, and 1. So they're all kind of close together. Our end behavior says that they're both increasing. So approximately our graph looks something like this. Up, back down. There you go. So that's an approximate sketch of what this looks like here. If we wanted a more detailed sketch, we would have to find min and max points, but that's a pretty approximate picture of what this polynomial looks like. All right, thank you for watching.